All right, for our next, for example, we're talking about people with O negative blood. People with no O negative blood are called universal donors because O negative blood can be given to anyone else regardless of the recipient's blood type. So if you know you're O negative blood, you should really make it like your life's mission to give blood all the time because you can donate blood to any person, whereas other people don't have that privilege. But about only 6% of people have O negative blood. So the probability of O negative blood is 0.06 or 6%. Donors are lined up at random for a blood drive. So we have these donors who are lined up randomly. And the question is, how many do you expect to examine before you find someone who has O negative blood? So yet again, you need to kind of read in the words that they're talking about a geometric scenario. How many people do we need to go through before finding O negative blood? So you're thinking the position of the first O negative blood. So as long as we feel that trials are independent, and if the people are lined up randomly, then we can probably go ahead and assume that they're independent. Probability of success is constant, 0.06. It does not change. Then and everything else is a failure, 2 outcomes. Then we do have a geometric scenario where the probability of success is 0.06. And we're going to let X be the position of first O negative, or the number of trials until an O negative. Same idea. So that's what the geometric model is. This question is an expected value. Where do you expect that value to be? That's the mean, which is 1 over P. Go to my calculator and type that in, and I get about 16.6 repeating. So about 16 or 17 people until an O negative. That's where we would expect the first position, the first O negative to fall. What is the probability that the first O negative donor found is one of the first 4 people in line? Now this is a little different than the previous question, although it's very similar. The previous question was, what's the probability the first real email was the 4th? This one is now, what is the probability the first O negative is one of the first 4th? So this means the first O negative could be in the first slot, or the first O negative could be in the second slot, or the first O negative could be in the third, or the first O negative could be in the 4th. We're actually talking about all of these scenarios added up. The way I write that in symbols would look like this. What is the probability that X is less than or equal to 4? Now technically when you're just less than 4, you could also include negative numbers. Negative numbers don't make sense because we're talking about actual people or trials. So we just kind of disregard that. But the way you find this is by calculating the probability of each one of these scenarios and adding them up. Because it's either the first O negative was in the first position, or second, or third, or 4th. Those 4ths mean we add. So the first O negative being in the first position is just equal to 0.06. Now we're going to add that to the probability that the first O negative is in the second position. So now we need them to not be O negative, that would be 0.94, one time, and then 0.06 for yes. Then we're going to add that to the third scenario where we have not O negative, not O negative, O negative. So now we have 0.94 times 0.94, so I can just use a square, times 0.06. And then the last one we need not, that's 0.94 cubed times 0.06. And each one of these is a little geometric formula where you have q to the x minus 1 times p. I don't have a q on this one because this was first position and 1 minus 1 is 0. So that would be no q. And then the 0.06. So you can kind of see a little pattern here. All right. And so now I'm going to go to my calculator and I'm going to sit here and I'm going to type all this in. And I'm sure you can imagine that if this number was bigger than 4, if it was something x is less than or equal to 10, this is going to take me a while. So that's where I want you to start processing that when we have these like probabilities that work in patterns. Let me just double check that I got my formulas right here. I got 0.06 for the first one, 0.94, 0.06. 0.94 squared, 0.06, 0.94 cubed, 0.06. All right, I get 0.2193. So that's the probability of X, the first O negative being one of the first four. So like I was saying, I'm sure you can imagine if this would have been a 10, we would have to keep going for a while, and that's going to take me a little while. So that's where we lead into calculator to the rescue. But I want you to notice that there is a pattern to this, to each one of these. There's a little pattern. The 0.94 is increasing in exponents each time, and the 0.06 is just remaining constant in that last position. When we have patterns like this, that's when we can start programming formulas and things in our calculator to just do them for us. So in your calculator, in the same spot where you had your normal model, there are other models in there. It's under second vars. Second vars. That's the distribution menu. Normal was your first choice, and we're going to learn, and we learned inverse norm. We're going to learn how to use some of these other ones, but at the very end, it's actually probably easier to scroll up than down. If you scroll up and go to the very end of the list, you have geometric back here, PDF and CDF, and we're going to learn how to use both of these. And there's your binomial ones, which we'll learn how to use in this chapter as well. So in your in this position under second vars, first thing is you have to decide, are you supposed to use PDF or CDF? In normal model, we always use CDF, never PDF. So geometric PDF finds the probability that your first success will be on the X trial. Geometric CDF finds the probability that your first success will be less than or equal to the X trial. So this one is what you use when you're finding the probability of X equals 4. This one you use when you're finding the probability of X is less than or equal to 4. So we're going to redo the last problem using the calculator. This one was a less than or equal to. So we want to make sure we use CDF. The C stands for cumulative. Cumulative means it's adding up. It's adding up the fourth one and all the ones before it. The fourth one, the third one, the second one, and the first one. Okay, that's what that C stands for, cumulative. So to do this, this is how you type it in your calculator. You do geom CDF, that is second vars choice E. Second vars choice E. Geom CDF. And then you got to learn how to what to type in. You type in P, probability of success, and then X. P was 0.06, and then comma X. X for that problem was 4. If it would have been one of the first 4, it's 4. If it's one of the first 8, it's 8. So in my calculator, geom CDF, the last choice, success is 6%, and we're looking for it to be the first success on the fourth trial. I press enter, and I get the same number. And if we would have done the previous problem with the spam email, that one was just equal to 4. That would be geom PDF. Probability of success on that problem was 0.09 and 4.0678, which was the answer to our last question. We calculated it outright, or we could have used these buttons on our calculator. That is the geometric model.